I was just wondering if,
हाँ जी.
um, yeah, I was just wondering if you could explain KW to me again because I didn't really fully understand it yesterday, and I was just
I
wondering if you could.
we didn't do KW, right? Actually, sorry, I'm on the wrong. Actually, it's not.
I think you wrote it. You wrote about it.
Actually,
Up
I did. I
further.
did. Just a second. ठीक है, this is yours. ठीक है, it's this one.
Okay.
अच्छा, so this was what KW was, that I told you that water ionizes, right? So water produces H plus 1 and OH ions, right? So, and I told you water has two ions, H plus 1 and OH ions. So sometimes in a neutral solution, you got both ions in equal amount. But if it's acidic, you get more H plus 1, you got lesser OH ions. If it's basic, you got more OH ions, you got less H plus 1 ions, right? So you know clear the importance of H and OH ions, right? Because all reactions are happening in water, right? So it's an equilibrium reaction. Water is in equilibrium with its ions. Is that clear?
Yeah, that's clear.
So your equilibrium constant would be product concentration divided by reactant concentration. So that's your expression, right? That's your Kc, right? Except that in Kc, what do we do? In Kc, what we do is that if water is in excess, you take its concentration to be constant, right? Is that clear?
Yeah.
So basically, your Kc expression is what? Your Kc expression is just the concentration of H plus ions multiplied by the concentration of OH ions, right? Water is a constant, so you take it as 1. Or in other words, basically you combine this constant with this constant and you take that as a single thing. So just keep this in mind that Kw is Kc basically, where you're taking water concentration to be constant because it's in large excess. Is that part clear?
Yeah.
So that's it. That's what Kw is. And now at room conditions, under standard conditions, the concentration of H plus 1 and OH ions, they're equal, right? It's 1 times 10 to the power minus 7 mole per dm cube of H plus 1 ions, and it's 1 times 10 power minus 7 mole per dm cube OH ions. So it's very less, but that's the concentration. And if you use those concentrations, the Kw value under standard conditions is going to come out to be 1 times 10 power minus 14. Is that clear? Is that part clear?
Yeah.
Achha, so and this value, this is an equilibrium constant. This value is always a constant, no matter what. It only changes with temperature. That's the only thing. It changes with temperature. It actually increases with temperature because at a higher temperature, water dissociates more. So you get more ions, so the Kw value is going to be a lot higher at a higher temperature. So it increases with temperature, but if you're not changing temperature, the value of Kw would remain exactly the same. ठीक है? तो इससे आगे ये कि this value would remain exactly the same no matter what type of water do you have. If the solution is acidic, the concentration of H plus ions is going to be a lot higher. Vice versa, the concentration of OH ion is going to be a lot lower, but the product would still come out to be the same. If vice versa, if it's basic, the concentration of OH ion is going to be a lot higher and the concentration of H plus is going to be a lot lower, but the product would still come out to be 1 times 10 power minus 14. Okay? Is this clear?
Yeah, it's clear now.
So water is everywhere. Like your blood has water in it. So it's got a Kw, which is 1 times 10 power minus 14. Okay? Your cells have water in your stomach has water in it. Every time the Kw value is going to be exactly the same if it's at room conditions. Okay? You're drinking water, it's going to have the same Kw. Except that the only difference is that every time the concentration of H plus and OH ions, that's going to vary. Sometimes one is higher, sometimes the other one is higher. Okay? So Kw is everywhere. And so what do you do with Kw? So basically we want to know reactions. Every reaction has a very specific pH. Every reaction requires a very specific amount of H plus 1 and OH ions. Some reactions need more of H plus 1, some need more of OH ions, right? So this ratio of H plus 1 and OH ions, that's very important. So you need to track it. Like if a farmer is planting plants in a soil, he's going to track the pH. He's going to track this ratio, okay? If the plant requires more H plus 1 and requires lesser OH ions, so he's going to track it. Okay, your stomach, your blood, etc. Everywhere, you're going to track your pH. That's the first thing, okay, when you want to check whether something is wrong or not. So KW, and you'll be making graphs for that. So KW is what? H plus 1 concentration multiplied by? Multiplied by OH ion concentration, right? Now, when you want to track the concentration of H plus 1 ions or the concentration of OH ions, you would need to make a graph. Now, the best thing to do with graphs is if you want to make a graph, you always use log. Do you know what log is?
Yeah, so it's used for powers.
Okay, but do you know what the purpose of log is? I mean, you do use log for a lot of things, but the the best thing it's used for is for making graphs. You know, if let's say if there's a farmer that's tracking the concentration of H plus ions, right? 1 month the concentration of H plus ions is like very low. Next month the concentration of H plus ions increases. It becomes 0.1 mole per dm cube. Okay, maybe there's a lot of acid rain. Can you plot the two values on the same graph? And if you are able to plot the value on the same graph, what would be the issue? Okay, it would be very hard to choose a scale, right? Because
Yeah.
one value is like really small, the other value is like really, I mean, relatively it's really big. So so the point is, okay, you can't really make a graph of values that have a big range. Okay, for example, you can't really plot 0.001 mole per dm cube, 0.1 mole per dm cube, maybe next day it's 10 mole 10 mole per dm cube. You can't really plot the three values on the same piece of graph paper. But if you take log, then you can actually. What's the log of this? This will be, I think, -5 because it's 10 to the power -5. This is 10 to the power -1, so this will be -1. This is 10 to the power 1, so that's 1. So if you go into log, then it's very easy to plot a graph because the values are -5, -1, and 1. Is that clear?
Yeah.
So log makes the values very manageable. And this is base 10. And normally when you take log, your values would then range from -10 to 10. I mean, all numbers in the that you're going to deal with would probably be, I mean, it's probably going to just fit it between these two numbers. I mean, the smallest value that you're going to deal with is probably going to be 10 power -10, right? The biggest value that you're going to deal with would probably be 10 power 10, right? So all your numbers would be within -10 to 10. So you'll end up with a nice graph, okay? So what you do is you take log on both sides. Now, when you take log on both sides, the KW value was log 1 times 10 power -14. And this will be log of concentration of H plus ions. Plus, now remember, when you're multiplying things, in terms of log, things get added up. But it basically is that if you're multiplying 10 power 2 with 10 power 3, right? So what's going to happen? It's going to be 10 power So when you're multiplying stuff, the powers are getting added up, right? It's 2 plus 3, that's equal to 5. Is that clear? So in terms of log, in the powers, things are getting added up when you're multiplying things. Okay, is this clear?
Yep, it's clear.
Okay, so remember this identity that A times B would be equal to log of A plus log of B. Multiplication turns to addition. Okay, when you're dealing with powers. Achha, so you get this thing. Now, when you get this thing, you multiply it by -1. Okay, and the only reason, I mean, there's no point in multiplying it with -1 except for one point, which is that most of the time the concentrations are going to be in decimals, right? Like, I mean, you don't have 100 mole per dm cube or 200 mole per dm cube or 1000 mole per dm cube. Most of the time, when you're dealing with concentrations, the numbers are in decimals. So if the numbers are in decimals, the log values are going to be negative. So instead of making a graph of negative values, you can just multiply the whole thing by -1 and you'll get rid of these negative values. So you'll make a better graph, right? Because you wouldn't be dealing with negative numbers. So that's why so it's just, I mean, there's no point in multiplying it with -1, except that you want to get rid of negative numbers. Is that clear?
Yep, it's clear.
So this will come out to be log of 10 power -14 was -14, right? But now it's going to come out to be 14. Minus log of H+ concentration is known as pH. And minus log of H+ OH ion concentration is known as POH. It's a term that's used. It's a term that's used uh, to describe the log of the concentration of H+ ions. So just remember that pH is basically equal to the negative log of the concentration of H+ ions. Vice versa, POH is referred to as the negative log of the concentration of. And if you add them up, it's going to come out to be equal to 14. Now, one of the reasons why you never hear about POH is that you don't really care about POH because if you know the concentration of H+ is high, then automatically you know the concentration of OHN is low. So you don't need to know both of them. You can just track one of them and you'll get the idea of the other one. Okay? So the idea is that no one really cares about POH because one value is sufficient to understand the other value. Is that clear?
Yep, it's clear.
Okay, so you just deal with pH. So that's it. So that's our first identity, which is pH plus pOH is equal to 14. Actually, there are two of them. One is Kw is equal to H+ concentration times OH ion concentration. The other one is, I mean, these two are exactly the same, except that you've just taken negative log of that, right? Otherwise, I mean, this expression and this expression are exactly the same expression. Okay? Acha, ab ye ke, what do you do with this? So the first thing we're going to do is we're going to try and calculate. We want to track pH, right? So the first thing we're going to try is how to calculate the pH of strong acid and strong bases. How do you how do you calculate the pH of strong acids and strong bases? Uh, so starting with now the thing with strong acids is that they fully ionize. As a strong acid, strong bases, they fully dissociate. So if I have HCl, HCl is a strong acid, so it's going to fully dissociate. It's going to produce H+1, and it's going to produce Cl-1. So there's not a big issue over here. Like if I have 0.15 mole per dm cube HCl, so I exactly know that the concentration of H+1 ions is going to be 0.15. It's going to be 0.15 mole per dm cube, okay? I exactly know that. So if I know that, calculating pH would be very easy. Like pH is what? pH is the negative log of the concentration of H+1 ions. So Varda, can you just use your calculator to figure this out? What is negative log 0.15? What do you get?
0.82.
So the pH of this HCl is 0.82. Similarly, if you have another strong acid like let's say like H2SO4, and let's assume it fully ionizes. So although it's not going to fully ionize, we did discuss this earlier, but let's assume that it fully ionizes. And let's say this is 0.05 mole per dm cube. तो आपका H+1 क्या होगा? That's going to be double the amount, so it's going to be 0.1 mole per dm cube. And
Why would it be double the amount if there's two hydrogens on that side as well?
on which side?
On the left.
Nee, there's
Or is it just the big
I
number in front?
हाँ ठीक है. We're talking about sulfuric acid. One sulfuric acid produces two H+1 ions, right? So if I have 10 molecules of sulfuric acid, the amount of H+1 ions is going to be double. It's going to be 20 H+1, right? So this 0.05 is for the whole sulfuric acid. If I've got this much, the amount of H+1 is going to be double the amount. Is that clear?
Okay, so it's the mole number at the front that you have to use to determine.
But it's basically the ratio, right?
But then isn't it balanced? Because there's two on the left as well.
लेकिन the thing is कि this number is not for it's not for the H+1 ions. This is for the whole sulfuric acid. Forget this number. Think about it that you've got one sulfuric acid, right? So
Okay.
how many H+1 ions are going to be produced? Two, right?
Yep.
So it's 1:2, right? You got one sulfuric acid, so that it produces two H+1 ions. You got 10 sulfuric acid molecules, it's going to produce 20 H+1 ions. So this number is for the whole sulfuric acid. You got 0.05 mole per dm cube sulfuric acid. The amount of H+1 ions is going to be double. Is that clear?
Yep.
अच्छा तो अब ये कि find what's the pH? It's going to be 1, right? Is this clear?
Yes, it's clear.
So similarly, what you can do is you can find the pH of bases. So if you've got NaOH and it's 0.015 mole per dm cube, NaOH. This NaOH would this NaOH would dissociate and it would produce 0.015 mole per dm cube. It's going to produce 0.015 mole per dm cube OH ions. Now the thing with NaOH is that you don't have H+1, so basically you're going to calculate POH. So So this is what you're going to get. POH will be minus log of 0.015, right? तो इसका find out करो, what do you get for POH?
1.82.
So you're going to get 1.82, right? But that's your POH, right? But you don't deal with POH. What did I tell you? That pH plus POH is what? 14? So what is your pH? Your pH will be 14 minus 1.82. So what do you get for this?
12.2. 12.17. 18.
ठीक है, 12.17. So basically this means that your OHN concentration this time was higher, right? So your pH came out to be 12.17. What that means is, what does 12.17 mean? It means that the concentration of H plus ions is basically equal to 10 to the power minus 12.17. And that's like a very, very low value. Is that clear?
I don't really understand.
In which part? You did get the part, I mean this part. You did get this part, right?
Yeah.
Okay, I told you that we normally calculate pH, right? But when it's a base, you don't have H plus one information. You got OH ions, right? So you calculate POH, right? From POH, you'll be able to figure out pH, right? Is that part clear?
Yeah.
So I was able to calculate the pH of a base, right? But do you know how to take the reverse log? Like, I've got pH. What was pH? pH is minus log of concentration of what? H plus ions? And that value is 12.17, right? So I'm going to take the negative sign to the other place, so that's log of the concentration of H plus ions, and that's coming out to be minus 12.17. And what does log do? It expresses values in the powers of 10, right? So the H plus 1 concentration would be what? 10 to the power minus 12. So I'm actually doing the reverse.
Oh, okay.
Okay. So when you get a very high value for pH, that actually means you got a very low concentration of H plus ions. Is that clear?
Yeah.
So the thing is that whenever you calculate the pH of a base, you don't actually calculate the pH. You actually calculate the pOH, right? Okay. So you actually calculate the pOH, and from pOH you'll be able to calculate the pH because we're just dealing with pH. And if pH is a very high value, that actually means the concentration of H plus 1 is actually very, very low. Okay. And remember, the scale is inverted. If pH or pOH, either of them, if you get a low value, that means a big value. And if you get a high value, that means it's a small value. Okay. If you get a big value, in reality, that means the concentration of H plus 1 is like very, very low. Is that clear?
Yep. That's clear.
Okay, so the scale is kind of inverted. It's like the other way around. And the reason it got inverted was that you multiplied it with -1 somewhere. Okay, यहाँ पे ना, you multiplied everything by -1. Whenever you multiply things by -1, your scale gets inverted. Like, for example, you got 535 is the bigger value. So if I multiply everything by -1, then it's the other way around. -3 is the bigger value. Okay. So because you had introduced a minus sign in all your values, you multiplied everything by -1, your scale got inverted. So it's basically this -1 that actually changes everything. Okay. अगर यहाँ पे ना, there was no -1, there was plus. I mean, if there had been plus 12.17, then a bigger value of pH would have meant a bigger value for H+1 concentration, but because of this extra minus sign, everything got inverted. The bigger value actually means a smaller value now. ठीक है, is this clear?
Yep.
अच्छा, अब ये कि अच्छा, and also remember this thing that you need to calculate pH. I mean, you need to know both things. Okay, so for example, if you have H% concentration equal to 0.001, right? So your pH is basically what negative log of the concentration of H+1, and that's going to come out to be क्या value आएगी if you take log of this? What do you get for this?
4.
ठीक है, so
4.
you're going to get 4. Vice versa, if you need to know the other way around as well. If pH is 4, then remember that basically means, I mean, you could just do it in one step. It basically means 10 power minus 4. Okay, so whenever you see pH 1, that means 10 power minus 1. Whenever you see pH 2, that means it's 10 to the power minus 2, right? Is that clear? I
Yes,
mean,
that's clear.
okay, it's this thing that if you see pH 12.17, uh, forget all the working, it just remembers that H% concentration is 10 to the power minus 12.17, right? So just keep this in mind. So try doing this one. I've got potassium hydroxide, and the pH is 13.1. Can you calculate the concentration of KOH? How would you do this? What's the first thing that you're going to do?
So do you write out the equation, or is that not necessary?
Yeah, you can write down the equation. So it's K plus 1 plus.
OH minus.
So now remember, for bases, you don't deal with pH, you deal with pOH. Okay? So the first thing for bases, because you've got OH ions, right? So the first thing is convert the pH into pOH. So what is the pOH?
0.9.
Okay, so your pOH is equal to 0.9. So if your pOH is equal to 0.9, what is the concentration of OH ions? मतलब क्या बताया था? What's the, you got pOH,
Is it 10 to the power minus 0.9?
so it's 10 power minus 0.9, right? And the concentration of OH ions and KOH is exactly the same. So figure out what 10 power minus 0.9 is.
Um, 0.13.
ठीक है, so it's 0.13 mole per dm cube. Try doing Another one, a question for sulfuric acid. Let's say you got sulfuric acid, and the pH is 1.8. So figure out what the fine concentration. Are you doing this one?
Yeah, I'm doing. I got 0.008.
What's the concentration of SSCR of 4? See. So the concentration of H plus ions comes out to be 10 power minus 1.8, right?
Yeah.
And the concentration of sulfuric acid is going to be half of that, right? And so this value comes out to be what?
0.008.
Take a 0 point. Any numbers after 0.008?
Oh, 0.0079244 is the actual thing. Is
Seven.
this supposed to be to 3 significant figures?
I think it's better to write up till 3 significant figures.
Okay.
ठीक है 0.00792 मोल per dm cube. ठीक है. So ठीक है. So we learned how to figure out pH. Remember that there's a because of this there's going to be a scale of pH. ठीक है. So you're going to have a pH scale where 7 is the middle part, that's pH 7. And when you move to the right, you become more basic. And when you move to the left, it becomes more. It becomes more acidic, ठीक है? So you've developed a pH scale based on that. And remember, pH 7 is not the middle, because pH 7 is only the middle if it's under standard conditions. Under standard conditions, जो होता है ना, the value, what is the concentration of H plus ions under standard conditions? That's 1 times 10 power minus 7 mole per dm cube, right? तो उसका अगर log ले तो you get 7, right? But if you do this at a higher temperature, your neutral point is somewhere else. Let's say at a higher temperature, it dissociates more. So you're going to get more H plus 1 and you're going to get more OH ions, and your value of Kw would also change. It's going to be higher. So अगर higher temperature में ना, this is 1 times 10 to the power minus 6, let's say. तो फिर मसला ये होगा कि your pH 6 would actually be your neutralization point. Does that make sense? Is that clear?
Could you just repeat the last sentence that you said again?
Yeah, I told you that, I mean, starting over here, I told you that under standard conditions, the H plus 1 and OH ion concentration is 1 times 10 power minus 7 mole per dm cube, right? Which is why you get a Kw value of 1 times 10 power minus 14. Is that clear?
Yep.
But if the temperature is higher, that means they're going to dissociate more. So maybe the concentration of H plus 1 and OH ions is going to be different at a different temperature. So agar higher temperature, you get more H plus 1 ions. You get 1 times 10 power minus 6 and you get 1 times 10 power minus 6. Your value of Kw would also change and your neutralization point would also change. You get your neutralization point, your concentration of H plus 1 ions is not 1 times 10 power minus 7. It's actually something else. So if you take log, you get a different pH. Is that clear?
Yep, it's clear. So only if temperature changes, no other condition.
So pH 7 is the neutralization point only if you are doing this under standard conditions. And Kw will have a value of 1 times 10 power minus 14 only if you're doing it at a standard conditions. Agar conditions change हुई है ना, and the concentration of the ions under standard conditions changes, then your Kw value also changes and your neutralization point, your midpoint, that would also change. ठीक है? You clear? Last thing, is that clear?
Yep.
ठीक है, so फिर tomorrow next class we'll do the other thing, which is weak acids. ठीक है? The only problem with weak
Okay.
acids is they're not going to ionize fully. तो issue ये होगा कि if you've got 0.15 mole per dm cube HCl, then the concentration of H plus 1 is not going to be 0.15 mole per dm cube. ठीक है? So it would be a lot harder to actually figure out the concentration of H plus 1 ions if the acid is weak. Is that clear?
Yep.
चलें ठीक है. Okay then, take care, Varda.
Okay. Thank you. Allah Hafiz.